The next few problems in our review are about trig substitution. In this integrand, we have a square root of 25 minus x squared. Whenever we have something of the form square root a squared minus u squared, where a is a constant and u is some function of x, it could be 4x squared, for example, then the u substitution, or the trig substitution that we do is u equal a sine theta. And that's the case here. So in this case, we're going to do x is equal to, in this case, a squared is equal to 25, or so a is equal to 5. So x is equal to 5 sine theta. And the derivative of x is equal to 5 cosine theta dx. So this is our substitution. Okay, so let's start substituting. So we have 25 minus 5 sine theta squared, that's 25 sine squared theta. And now for dx we put 5 cos theta. This should be d theta. Now notice I dropped the limits from 0 to 5 because these are x limits, not theta limits. When we switch back to x, then we'll bring back the limits. Okay, underneath the square root here, what's going on? We have 25 times 1 minus sine squared theta under the square root. And 1 minus sine squared theta, that's equal to cosine theta. So under the square root, we have 25 cos squared theta. So now let's go ahead and take the square root. So that would be 5 cos theta times 5 cos theta. Alright, so that's 25 times the integral of cos squared theta d theta. And we're going to use our half-angle formula to, our half-angle trig identity, I should say. Okay, and that's cos squared theta is equal to 1/2 1 plus cos 2 theta. So let's use this to integrate cos squared theta. I'll put the 1/2 on the outside. Okay, so now we're ready to integrate. The integral of 1 is theta, and the integral of cos 2 theta, well, we have the derivative of sine 2 theta is 2 cos 2 theta, so that would be 1/2 sine 2 theta to make up for we put the 1/2 here because to make up for the fact that we don't have the 2 in front of the cosine theta. Cosine 2 theta. Okay, now let's switch back to x, our x variable. So remember, here's the substitution that we did. We did x equal 5 sine theta. All right, so that would be that would be x over 5 is equal to sine theta. So theta is arc sine x over 5. Okay, now here we have sine 2 theta. Now from the little triangle that we're going to draw, let's do it now, we can get values of the other trig functions of theta, but not of 2 theta. So we need to do a trig substitution, and we'll write sine 2 theta is equal to 2 sine theta cos theta. That's called the double angle formula. So we're going to substitute for sine theta and cosine theta. This 2 and the 1/2 cancel. Okay, so for sine theta, we have x over 5, that's opposite, over hypotenuse. And this adjacent side over here is, by the Pythagorean theorem, 25 minus square root 25 minus x squared. Okay, now, like I said, the 1/2 and the 2 cancel, so let me erase this 1/2 over here. Let me just erase that. Okay, so I'm going to put, for sine theta, we put x over 5. And cosine theta adjacent over hypotenuse, so we have square root 25 minus x squared divided by 5. And now we're ready to put in our limits, so let's do that. Our limits here from 0 to 5. Okay, so we'll start our substituting. Okay, let's start substituting. Okay, oops, just a minute. Put this back. Okay, so first we'll substitute 5. And we have arc sine, 5 over 5, that's 1, plus, here when we substitute in 5 into 25 minus x squared, we have 25 minus 25, so that's 0. And when we substitute in 0, we have arc sine 0 is 0. And this second term also is 0 because of this x. So this is what we have, 25 over 2 arc sine 1. And the angle whose sine is 1 is pi over 2. So we get 25 pi over 4. Okay, number 14 is another integral that could be done using a trig substitution. When we have an integral with something of the form u squared plus a squared, sometimes underneath a square root but not necessarily, then sometimes it helps to do the substitution u is equal to a tan theta. So in our case, we have a squared is equal to 3, so a is the square root of 3. So we're going to do the substitution x is equal to the square root of 3 tan theta. And so dx is equal to the square root of 3 secant squared theta d theta. All right, so let's go ahead and do our substitution. X squared, that's 3 tan squared theta, plus 3. And for dx, we have square root 3 secant squared theta d theta. Okay, let's, I'm going to just take out that square root 3. Okay. Now, tan squared theta plus 1 is equal to secant squared theta. So here we have 3 times tan squared theta plus 1. All right, so here we have this is 3 tan squared theta plus 1. So that's 3 secant squared theta underneath the square root. So let's take the square root of that. So we have the square root of 3 secant theta. And we still have this exponent 3. We took the square root. There's the square root. But we still have the exponent 3 up here. Alright, so let's cube this denominator. Okay, so when we cube the denominator, we get 3 square root 3. And then we have secant squared theta. And we have secant cubed theta. Okay, and of course we're going to do some canceling. And here as well. So that's equal to 1/3. And we have 1 over secant theta d theta, which is 1/3 cos theta. And now we can integrate that, and we have 1/3 sine theta. Okay, now we have to put x back, go back to our original substitution, and we have x over square root 3 is equal to tan theta. So to figure out sine theta, we'll draw a little triangle. So that's opposite and that's adjacent. And the hypotenuse is the square root of x squared plus 3. Okay, so sine theta is x over the square root of x squared plus 3. So we get 1/3 x divided by the square root of x squared plus 3 plus a constant. Here's another integral that could use a trig substitution. Something of the form, something that has a square root u squared minus a squared. Something of this form could sometimes be solved with the trig substitution u equal a secant theta. So in our case, we have x is equal to 2 secant theta. Here, a squared is equal to 4. So dx is equal to 2 secant theta tangent theta d theta. All right, now we're ready to substitute. Cube this, and we have 8 secant cubed theta. Square root, square this, and we have 4 secant squared theta minus 4. And for dx, we have 2 secant theta tangent theta d theta. Okay, let me just... All right. Okay, now let's look at this. So this is 4 times secant squared theta minus 1. And secant squared theta minus 1 is tan squared theta. So underneath the square root, we have 4 tan squared theta. And now we'll take the square root. So that's 8 secant cubed theta times 2 tan theta, after we take the square root, times 2 secant theta tan theta d theta. All right, first of all, let's multiply all these constants. We have 8 times 2 is 16 times 2 is 32. So that's 32 on the outside. Now the secants. Secant cubed times secant. That's secant to the 4th. Tangent times tangent, that's tangent squared. All right, this is a trig integral, and it has an even power of secant, so we can pull off a secant squared and put it next to the d theta. And this will be our du. So we want u equal tangent theta. And we want to change everything here to tangent, so we'll change secant squared theta, that's tan squared theta plus 1. Okay, so this is equal to 32 times the integral. Now start the substituting, u equal tan theta, u squared plus 1, u squared du. So that's u to the fourth plus u squared du. And now do the integration. And now substitute back, u is equal to tangent theta. And now we have to substitute once again. Okay, our original integral was in terms of x, so we'll go back to this substitution, x equal 2 secant theta, or x over 2 is equal to secant theta. So let me write that over here. And we want to know what tangent theta is, because we have tangent theta in our solution. So secant's 1 over cosine. So this is hypotenuse over adjacent. And the third side is square root x squared minus 4. Okay, so tangent is square root x squared minus 4 over 2. All right, so finally, we'll get our integral in terms of x. Okay, so we can put the 1/5 here, and we have square root x squared minus 4 over 2 to the 5th. And then I'll put the 1/3 over here. And again, tangent square root x squared minus 4 over 2 cubed. And now I'll add in the plus c. So there we have our solution.